Okay, next step is an application of our vector cross product. So this is our formula, sine theta. Okay, now if we go back to year 9 and an area of a triangle, if I have two sides A and B, and I have an angle between those sides, well, I know that the area of a triangle is half base times height. Okay, the height of this triangle I can write as using that angle, an A, and that is opposite. So opposite is sine, I think. Yes. So the height is A sine theta. So this area then is half of AB sine theta. Okay, so you may or may not recall that formula. But if you look at that formula and then you look at the cross product formula, they are a little bit similar. So what this tells us is that if we have two vectors, A and B, with an angle between them, this area of this triangle is, so this area is going to be the magnitude of A, well, half in front, half the magnitude of A times the magnitude of B times the sine of the angle, which is, another way to write that would just be half of the cross product of A and B, and I put those lines here just because all we're interested in is the magnitude of that cross product. We don't make it a vector, so we don't need that. We don't need this part. Okay, so that's just the magnitude. So another thing is we could make a parallelogram out of that. Let's have again A and B, and if I copied my vector A down here, and I copied my vector B over here, that gives me a shape of a parallelogram. Let's try that again. Parallelogram. And of course the area of that parallelogram is just without the half. Just the cross product of A and B. The magnitude of the cross product. That's it. So an example. Calculate the area of triangle OAB, where A is, let's say, 1, 2, minus 1, B is 3, 0, 2. Okay, so in 3 dimensions, and O, of course, O is the origin, O, O, O. Okay, so the area of this triangle, so the area is going to be half of, if we make A a vector, times the vector B, the magnitude of that. Okay, the vector A, over here A is, we just replace those coordinates and put them in I, J, K. So A is I plus 2J minus K. B is 3I minus plus 2K, no J. Okay, so this area is 1/2, and the magnitude now, we're doing this determinant. So really we need a magnitude, and we're doing another magnitude inside that. A bit confusing, but we've got this I, J, K, 1, 2, minus 1, 3, 0, 2. Just to explain again, this inner set of lines is my determinant, the outer set is the magnitude. So, magnitude of, let's just work this whole thing out. I times 2 times 2 minus 0 times minus 1, that's 4i. Okay, minus j times 1 times 2 is 2 minus a negative 3, so that's 5, so that's a minus 5j. K, 1 times 0, that's 0, minus 6, we'll go minus 6k, I believe. Okay, so, so this middle part is my cross product, and we're trying to find the magnitude of that cross product. So that magnitude of a cross product, you just square each of the numbers. It's just three-dimensional Pythagoras, so that's minus 5 squared and a minus 6 squared. Okay, so half of square root of 16 plus 25 plus 36. That's at 41, 36, 77, half square root of 77, whatever that is. Okay, so that is the area of that particular triangle.